Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everybody. Today, our lesson in chapter 8, lesson 3, solving right triangles. In this video, we will use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. San Francisco, California is famous for its steep streets. The steepness of a road is often expressed as a percent grade. Filbert Street, the steepest street in San Francisco, has a 31.5% grade. This means the road rises 31.5 feet over a horizontal distance of 100 feet, which is equivalent to 17.5 degree angle. You can use trigonometric ratios to change a percent grade to an angle measure. Let's see example 1. If we have a right triangle like this triangle, which contains a right angle here and two acute angles, angle number 1 and angle number 2, and the three sides, which are the hypotenuse 5 feet long and the two legs, the short leg 1.4 feet and 4.8 feet. Use the trigonometric ratio cosine A equals 24/25 to determine which angle of the triangle is angle A. In other words, we want to determine which angle of the two angles, 1 or 2, that its cosine is equal to 24/25. So, to solve this question, we know that cosine is the ratio of the adjacent leg to the hypotenuse from the previous lesson. So, the leg adjacent to the angle number 1, which is 1.4 feet long, and the hypotenuse is 5 feet. So, if angle A is angle number 1, its cosine must be 1.4/5, which is 7/25. So, angle A is not angle number 1. Let's check angle number 2. The leg adjacent to angle number 2 is 4.8 and the hypotenuse is 5. So cosine angle 2 equals 4.8, the leg adjacent, over 5, the hypotenuse, which is equal to 24/25. So now, which of the two angles will be angle number or angle A, 1 or 2? Yes, it's angle 2. Now we have check it out. Please stop the video and solve it alone. Then come to check your answer. Let's see. Sine angle A, which is the opposite leg over the hypotenuse. So, if we start with angle number 1 and find its sine, which is 27, the opposite to angle number 1 is the leg 27, over the hypotenuse, which is 30.6. Simplify the result, you will find it 0.88, which is not equal to 8/17. Now, angle number 2. The leg adjacent to angle number 2 is the leg adjacent to angle. No, we don't need the adjacent. It's a mistake in the PowerPoint. The leg opposite to angle number 2 is 14.4. And the hypotenuse is 30.6. So, to find sine of angle number 2, we will find the ratio between 14.4 and 30.6, the opposite leg and the hypotenuse, which is equal to 0.47. So, since sine angle A is equal to sine angle 2, so angle 2 is angle A. Now, another checked out. Please try it alone. Okay, let's check your answer. We know that tangent is the ratio of the opposite leg to the adjacent leg. So tan angle A is equal to opposite leg over adjacent leg. Let's start with angle number 1. Its opposite, the opposite to the angle number 1 is 14.4 or 27. We said the opposite. So the opposite is 27 over the adjacent which is 14.4. So tangent angle number 1, 27 the opposite over 14.4 the adjacent, which is equal 1.875. So since, and we know that angle number 2, its tangent is the opposite for angle number 2, 14.4 over 27, the adjacent, which is 0.53. So since tangent of the angle A is equal to tangent of the angle 1, so angle 1 is angle A. Remember, in the previous lesson, you learned that sine 30, you can calculate it with your calculator or with a special right triangle, which is equal 0.5 or half. Conversely, if you know that the sine of an acute angle is 0.5, you can conclude that the angle measures 30 degrees. This is written as sine power -1 of 0.5 is equal to 30 degrees, which is the inverse operation, okay, of sine, or the inverse function of sine. If you know the sine or cosine or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measure of the angle. Let's see. If sine any angle, like sine angle A, equals x, then sine -1 of x of the answer, sine -1 of the answer of x is equal to measure of angle A. So we're gonna use this rule to find the measure of any angle if I know its sine. Also, I can use this rule if I know its cosine. It will be measure of the angle A also. equals cosine power -1 of x. Also, we can use this rule or the same rule when we know tangent of an angle. Let's see example number 2. Use your calculator to find each angle measure to the nearest degree. The first one, if you know that cosine power -1 of 0.87, so please find the measure of the angle to nearest degree. It means we don't need to write a decimal after degree. So I will press on my calculator cosine power -1. How? You have shift on the calculator, so please press shift first, then press cosine, then write the number 0.87. It will be approximately 30 degrees. The second one, you will press shift, then sine, and write the number 0.85. It will be 58 degrees approximately. Also the third one, yes, excellent. It will be shift, then tangent, then write 0.71. Press equal. It will be approximately 35 degrees. Now we have checked out, and you have, I think, 1 minute to solve this because you will use your calculator. Okay, let's check the answers. The first one approximately 35 degrees. The second one approximately equals 87 degrees. And the third one approximately 42 degrees. Now, using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. If you ask yourself, what the meaning of solving triangle? We know that any triangle, okay, contains 6 elements, 3 sides, and also 3 angles. So to solve a right triangle, you need to know at least 2 side length or 1 side length and an acute angle measure. Let's see example 3, solving right triangles. We have in the given figure a triangle RST, which is right triangle, and we know how many side lengths here. Yes, we know 2 side lengths, SR and RT. So we want to solve this triangle. Solve this triangle. It means you will not find only a required side or required angle. No, you will solve all the triangle. It means you will find any side length or any angle is not here. Last year in grade 7 and also in the first term, we use Pythagorean theorem, and we know that Pythagorean theorem, if we know 2 side lengths of a right triangle and we want to find the length of the third side, we use Pythagorean theorem. We can write Pythagorean theorem as the hypotenuse squared, the hypotenuse, which is the longest side, which is RT, which is opposite to the angle 90, opposite to the right angle. This is called the hypotenuse. Okay, so the hypotenuse squared equals the sum, means plus, of the two squares of the other two legs or the other two sides of the right triangle. So if you apply this theorem in this question, substitute by the length of RT, the hypotenuse, which is 5.7, and put square equals RS squared, means 5 squared, and the unknown or the third side, which is ST. I don't know the length of this side ST, so I'm gonna write it ST squared as it is and consider it like X in an equation, and you can solve this equation. Okay, so you're gonna consider it ST as X in an equation. Okay, now you can solve this question. We can subtract directly because we will use our calculator, like ST squared equals 5 point ST, look, if ST squared, which is like X squared, equals 5.7 squared minus 5 power 2, it will be 7.49. Then to find the length of ST without this power 2, we will use the positive square root. Ask yourself why in this question we use only the positive square root. Yes, because ST represents the length of a side, and the length of the side cannot be negative. So we will use only the positive square root to cancel this power 2. It will be approximately 2.74. Remember in the question, round the length to the nearest hundredth. Now, the second required to find measure of angle. We learned now in this lesson that to find measure of angle, can use the inverse function if I know a function. Look at the given triangle again. You know the hypotenuse, which is 5.7, and another side, okay? And also we found the third side, but depend on the two given sides. We have hypotenuse, one of them. This 5, we can consider it as the adjacent leg for angle R or the opposite leg for angle T. Anyway, if you considered that 5 is the adjacent leg for angle R, so you can use the inverse function of cosine. So you can write measure angle R equals cosine power -1 adjacent leg over the hypotenuse, and by using your calculator it will be 29 degrees. Also you can find measure angle T, okay, by using sine or the inverse function of sine. You can write the same, measure angle T, not measure angle R. Measure angle T equals sine power -1, 5 over 5.7, and you will get the measure of the angle T. And because we know that the two acute angles in this right triangle or in any right triangle are complementary, it means the sum of their measures equals 90 degrees. So measure angle T equals 90 minus 29 degrees, which is approximately 61 degrees. This is the second method we can find also measure angle R first, and also measure angle T, then find the third side. We will not use Pythagorean here. We can use any trigonometric ratio. We can use sine the angle R, its opposite leg ST, over the hypotenuse 5.7, like the lesson of yesterday or the previous lesson. So we can simplify by multiplying both sides by 5.7, or we can divide them like this. Look, ST is equal 5.7 times sine R. So ST is equal 5.7 times sine, the angle, which is angle R, which is, or cosine power negative 1, 5 over 5.7. Try to read it again. Here we can replace this and put 29, but we prefer to put it as it is, okay? Because here we wrote it rounded. So if you put it 29, it will be the same, but nearest to the result, not accurate, okay? So we put it as cosine power negative 1, 5 over 5.7. Now check it out 3, you can solve it alone. Now check the answer. If you know an acute angle in the right triangle, so I can find the third angle. Yes, 90 minus 58, which is 32 degrees. Now I can use any of the ratios like sine or cosine or tan, okay? So here to find, we know angle D, which is 32, okay? So tan angle D, which is its opposite leg, FE over the adjacent leg, 14, okay? And then multiply both sides by 14, the denominator. It will be 14 times tan 32. With your calculator, you can find it. It will be 8.75. And find the third side by using the same way or by using Pythagorean theorem. I know that maybe someone want to tell me that he can solve this question with another way, but the problem here to see the result, okay, if your answer is approximately 8.75, so it's a true way. Now example number 4, the right triangle in the coordinate plane, the coordinates of the vertices of triangle PQR are P, negative 3 and 3, Q, 2 and 3, and R, negative 3 and negative 4. Find the side lengths to the nearest hundredths and the angle measures to the nearest degree. Let's plot the points first. Find the side lengths, plot the points P, Q, and R. We have now this triangle is right triangle because we have the side PQ parallel to the horizontal axis and the side PR parallel to the vertical axis. So they are perpendicular. So we have here right angle. Now we know the right angle, and also we can calculate the length of PQ and the length of PR by counting here PQ 1, 2, 3, 4, 5 units, and the length of PR 1, 2, 3, 4, 5, 6, 7. Now the length of RQ, you can find it by using by using Pythagorean, okay, yes. So, or you can find it using distance formula, they are the same. It will be approximately 8.60. Now I have the three side lengths of the triangle. We want to find one acute angle, R or Q, any one of them, and the second angle will be the complementary for this angle. So to find the angle measure, we know that measure angle B is 90, and if you look from angle Q, you will find that RP is the opposite leg for the angle Q, and PQ is the adjacent leg for angle Q. So opposite and adjacent, you can find this in tangent, yes. And because we want to find measure of angle, and I know length of sides, so gonna use the inverse function of tangent, which is tan power -1 or tangent -1 of the opposite side 7 over the adjacent side 5, which is approximately 54 degrees. So the other acute angle, which is angle R, sorry, this is not S, it's angle R, okay, equals 90 minus measure angle Q equals 36 degree approximately. Now check it out. Let's check the answers. We have right triangle, yes. You can count to calculate RS and ST. Is this isosceles right triangle? If you concentrate with me now, I can find the measure of angle T or angle R only if I see isosceles right triangle. So measure angle R and measure angle T equals, try to answer. Yes, it's 45. Now find the distance formula. By using the distance formula, you can find RT, which is 7√2 in the previous lesson. Check it out if you remember. If I have isosceles right triangle, the legs 7, so the hypotenuse will be 7√2 without doing all this. And also the angle here is 45, but you can find it using the same rule, okay? Tangent 7 over 7, which is 1. Which angle? It's 10 was 1. Excellent, 45 from the previous lesson also. Anyway, example number 5 and the last example in this session. A highway sign warns that a section of road ahead has a 7% grade. To the nearest degree, what angle does the road make with a horizontal line? Yes, we can change the percent grade to a fraction, which 7% means 7 over 100. Why we convert it to fraction? Yes, this percent, we can write it as fraction 7 over 100 to make it like the rise over the run, which is 7 over 100. 7% grade means the road rises or falls down 7 feet for every 100 feet of the horizontal distance. So we have now right triangle like this. Every 100 feet, the root rises 7 feet or falls 7 feet down. So we have triangle now, and the question, to the nearest degree, what is the angle does the root which is AC, represented by AC, with the horizontal, which is AB. So we need measure angle A. We convert all this problem to problem in our lesson to find measure of angle. And we know lengths of two sides in a right triangle. So the two sides here represent 7, which is opposite to angle A, 100, which is adjacent for the angle A. So we can use tangent or the inverse function of the tangent of 7 over 100, which is approximately 4 degrees. Now check it out. Let's check the answers. The same steps, the same tan, which is 21. Now we have this quiz. Please stop the video and then solve this quiz. Please send me the answers if you finished, and I will see you inshallah tomorrow. Goodbye and good luck for all.